Hello friends, in the previous video we have seen the moment of inertia. Now this is your new chapter, that is simple stresses and strains. See, this is also very important chapter. Here in the syllabus topic we have different points. In the syllabus we have the definition of stress, strain, Hooke's law, elastic limit, what is meant by uniaxial, what is meant by biaxial and triaxial stresses, tensile and compressive stresses, shear stresses, principal stresses and strains. One more important thing, that is Moore's circle. We in this chapter we will see elastic constants also, like modulus of elasticity, modulus of rigidity, bulk modulus, Poisson's ratio, then yield stress, ultimate stress. See, few important points are there which are required to solve the problem. What is meant by factor of safety, state of simple shear, relation between elastic constants, volumetric strain for triaxial loading, deformation of tapering members, deformation due to self-weight, bars of varying section, composite section, and one more important topic, that is thermal stresses and strain. See, you can see so many syllabus topics are there because this is very important chapter in strength of material. We have to use different formulas to solve the problem in this chapter. See, what is meant by strength of material? It is also known as mechanics of deformable bodies. When the body is subjected to applied load, it gets deformed either in elongation, shortening, twisting, bending of a member. During the process of deformation, body develops an internal resistance against applied force. The ultimate internal resistance to the applied force is depend on the type of deformation in a body properties of materials. Hence, the strength of material is defined as the strength of member and behavior of materials when subjected to the external force. See, in the strength of material, this is a very interesting topic, interesting chapter. We know the different mechanical properties of materials. In the material technology, we will see what is meant by strength, what is meant by plasticity, then elasticity, ductility, malleability, hardness, resilience, fatigue, toughness, stiffness, and grip. These are the mechanical properties. See, in the E content, I have given the detailed definitions. Here in the video, I'm not explaining each and everything, but you have to refer E content to get the entire knowledge about each and every definition, or you can see the mechanical properties of materials like strength, plasticity. You can read each and everything in the E content. Here I am explaining you the important points. See, this is your strength, elasticity. See, while reading the E content, you have to take highlighter because here I am explaining the things which are required to solve the university problems. Because see, we have so many, or you can say the large content, but you have to highlight important things. So while doing the practice, while solving the problems, you will feel easy See, this is a definition of for plasticity. You know what is by ductility, what is by hardness, what is by brittleness, what is by malleability, what is mean by toughness, what is by stiffness, what is by strain hardening. See, the entire things we will cover in the material technology subject. Here, just I am telling you the different mechanical properties. See, but in our syllabus topic, we have the definition of stress and strain. So you should aware with the different stresses, what in by stress, what in by strain. So you can see this diagram. In this diagram, the area is given in the two-dimensional diagram. The area is given. Here, load is acting P. P is the external load. You can see here. See, this one is XX section. You can see in this diagram. Here you can see R is the resisting force. You can see R is the resisting force. Here P is the applied load. Here this is your R, that is resisting force, and here that is applied load. See, this one is the entire diagram, entire area. Now here at given cross section, the diagram is divided into two parts. This one is the first and this one is second. R indicates resisting force. P is applied load acting away from the body. You can see P is acting away from the body. Here you can see P is acting away from the body. Here P is acting away from the body. So what is by stress? The internal resistance setup per unit cross-sectional area is called as a stress, or intensity of stress or unit stress. It is denoted by sigma. So sigma is nothing but R upon A. See, here R is the resisting force and A is the cross-sectional area. That is very, very, very important. A is the cross-sectional area. So in the equilibrium condition, the internal resistance R is equal to the external load P. So here you can see in this diagram, R is equal to P. So R is equal to P. So in the formula, we are taking, instead of R, we are taking P. So sigma is equal to P upon A. See, P is the load acting on the body. A is the cross-sectional area of the body. That is very, very important. A is the cross-sectional area of the body. And sigma is nothing but your stress. So stress is equal to P upon cross-sectional area. Load acting on a body upon cross-sectional area. So mathematically, stress may be defined as a force per unit cross-sectional area. Per unit cross-sectional area. So we know that the SI unit of force, that is Newton, and unit of area, that is meter square. So unit will be Newton per meter square. So 1 Pascal is equal to 1 Newton per meter square. Other unit of stresses are kilopascal, that is kPa, megapascal, that is MPa, gigapascal, that is GPa, etc. See, you have to note down this thing. You have to highlight this thing. 1 Pascal is equal to 1 Newton per meter square. So 1 kPa is equal to 10 raised to 3 Pascal, is nothing but 10 raised to 3 Newton per meter square. 1 megapascal is equal to 10 raised to 6 Pascal, that is 10 raised to 6 Newton per meter square. And 1 gigapascal is equal to 10 raised to 9 Pascal, that is 10 raised to 9 Newton per meter square. You can see kilo, that is 10 raised to 3, mega, that is 10 raised to 6, and giga, that is 10 raised to 9. Next thing, what is meant by strain? Strain is simply a measure of deformation produced in a member due to the load acting on it. It is defined as the ratio of change in length to the original length of a member. You can see strain is equal to change in length upon original length. You can say that change in dimension upon original dimension. Here in this diagram, specimen is given. Is after putting this tensile load, tensile force, the size of this specimen will increase. The change in length, that is delta L, and this one is the original length. So the formula will be strain is equal to delta L upon L. Here delta L is change in length of the body and L is the original length of body. See, in the next video, we will see the different and very important points related to this chapter. Thank you.